Alright, I intentionally separated this type of matrix into its own lecture to show its significance and importance. This is the zeros matrix. It's a matrix filled with zeros. The way to use the zeros function is just like with the ones and the I. You give it the size that you want and it will create a matrix of that size filled with zeros. So zeros of 5 will create a 5 by 5 matrix of zeros. And all of the other ways of creating a matrix with these functions that I showed you for the I and the ones function are the same. Now, you might be wondering, why would you ever need to create a matrix filled with zeros? It's a valid question that we will explore now. While in math you may need it for some complex mathematical issues, that is not what we use it for in MATLAB. The zeros matrix is extremely useful in MATLAB for other reasons. It's useful for pre-allocating memory space for your further calculations. This will make your calculations faster, and not just faster, at least 10 times faster. And I will show you a very simple example taken from a paper that Christo and I wrote a few years ago while I was still a student. So I will just copy and paste the example. The example is the following. Now, this example, as you can see, includes two for loops, and don't bother with for loops yet. We will see them very shortly and you'll understand so many things about them. The idea here is that the way that these for loops are currently structured, they are simply made to go over the whole matrix one by one through each element. The idea is to find which of the approaches will do it faster. As you can see in the first example, we have pre-allocated memory for our matrix. So we created a matrix of zeros, and this matrix is 3000 rows by 3000 columns. And in the second example, we don't have this. We don't have a zeros matrix prepared before we start. And we use ticker the time for each of these operations, how much time it will take for each of these operations. Notice that I also included the creation of the zeros matrix within our measurement. Let's run the code and see what will happen. Let's run it. So run. So the first approach took 0.14 seconds. As you can see, the second approach is still running. So let's just wait for that second approach. So let's look at seconds here. So it took 14.5 seconds. It took 100 times longer. 100 times longer. It took 100 times more time to accomplish the same task. Here we have the zeros. Here we don't have a zeros pre-allocation. Now let's increase this even more. We can make it with 30,000. So 30,000. Let's run it, and here it will take a bit more time. As you can see, it will even load up my memory. Currently MATLAB takes about 7 gigabytes of memory. So just be very careful when you perform such kind of tests, because you may run out of memory, your computer may freeze. So let's just see. So the first way, with the zero pre-allocation, it took 24 seconds. Now, obviously, the second way will take minutes, but let's just wait a couple of seconds and see what will happen. So as you can see, the memory on my MATLAB, the memory that my MATLAB consumes is slowly going up and up and up. While with the zeros pre-allocated, we immediately started at 7 gigabytes. We immediately had all of the necessary memory pre-allocated. I'm going to interrupt it. You can interrupt it by pressing Ctrl and C in the command window. And you can see down here with the I and the J variables that we have. So with the I and the J, the I is on the 1500 row. So this is the importance of using zeros. Whenever you're working with data, as soon as that data starts getting bigger and bigger and bigger, make sure to pre-allocate space for that data because this will tremendously increase the speed of your code. Make it a habit.